take this example on current electricity about resistors in series and parallel. This is WAEC exam question 1994. So here's the diagram above, and the question says calculate the effective resistance between point X and Y in the diagram above. So this question is saying we should calculate the effective resistance or the equivalent resistance between this point X and point Y. So how are we going to do this? First, we've learned about analysis of resistors in series, and we've also learned that of parallel. So there are three resistors here: 20 ohms, 5 ohms, and 4 ohms resistors. So the first thing we are going to do is to identify what kind of connection they have. Is this a series connection or a parallel connection? Now, what will be your answer? Well, if you ask me, this is a parallel connection. Reason being that the three resistors share the same terminal. Like this first resistor here, 20 ohms, the front of it shares the same terminal where with the front of 4 ohms, and the front of 5 ohms also shares that same terminal. So you see both of them, this particular point here, they share the same X point. You know, this point X here is the same as this place here. It's still the same terminal that they have. Then if you look at the back of the resistors, the back of this one and the back of this one, you see they are still connected at the same point. Why? So this is what a parallel connection. So what this means is so if you are to redraw that in a way that is more suitable for understanding, you see that what you actually have here is this. This is what you actually have there, and all of them have the same back. So this is your X and this is your Y, and this is your 20 ohms, and this is your 4 ohms, and this is your 5 ohms. So it's a parallel connection. So now let's analyze that and see. Let's calculate the effective resistance there. So remember, for resistance connected in parallel, effective resistance is calculated as 1 over R equivalent, or R effective resistance, or R total, be equals to what? 1 over R1 plus 1 over R2 plus 1 over R3. So that means our 1 over R equivalent will be equals to 1 over 20, that's the first resistor, plus 1 over 4 plus 1 over 5. 1 over 5. So the next thing we're going to do is to find the LCM of the denominators. So we have a 1 over R equivalent be equals to the LCM of 24 and 5 is 20. LCM of 24 and 5 is 20. So we write 20 there on the bottom. 20 divided 21, 1 times 1, 1, plus 4 divided 25, 5 times 1, 5. 5 divided 24, 4 times 1, 4. Okay, so we now have 1 over R equivalent to be equals to, we add the numerators. 1 plus 5 is 6, plus 4, 10. That will be 10 over 20. Then we take reciprocal of both sides. When we take reciprocal, that's we take the denominator to the numerator and the numerator to the denominator, both sides. So this would be R equivalent will now be equals to what? 20 over 10. Of course, 10 will cancel itself 1 and cancel 22 times. So therefore, the effective resistance will be equals to what? 2 ohms. So it's as simple as that.